Now we turn to the second task, where u were supposed to be the sine of x1 multiplied with cosine of x2, and do the same for these functions. For this function, computing this integral in the same way as before, we obtain that this integrand is of course less than 1, because sine and cosine is less than 1, both of them, and squaring it gives us a positive value, so we are sure that this value must be between 0 and 1. Therefore we are sure that this is less than this integral, where we have replaced the actual integral with just 1. And taking this integral, we find that the value is 1. This means that since 1 is less than infinity, this means that u is a member of L2. Okay, then we take the partial derivative of u with respect to x1, and it's also easy. The partial derivative, the derivative of sine is cosine, so we obtain this expression. Moreover, the partial derivative of u with respect to x2 is just equal to minus sinus x1 sinus x2. So here we have just taken the derivative of cosine, which is minus sine. And we now compute this integral. We know that this is less than, in absolute value, it's less than 1. So we do exactly as we did above. This is less than the integral of 1 over 1, which is equal to 1, which is also less than infinity. So we conclude that the partial derivative of u with respect to x1 is a member of L2. In the same way, we obtain that the partial derivative of u with respect to x2 is a member of L2. So we know that u is a member of W1, 2. Now we try to answer the question whether u is a member of W pair, and what we are going to check is whether u of 0 in this point x2 is equal to u of 2 pi x2, because remember that our omega is now from 0 to 2 pi and from 0 to 2 pi in the y direction as well. So how can we proceed here? Well, we just we just find the value of u0 x2 by replacing x1 with 0. Doing this, we obtain sinus of 0 multiplied with cosine to x2. So this is equal to this. So we are going to find, we are going to consider whether this is equal to u of 2 pi x2. We do the same for inserting 2 pi instead of x1 here, and get sine 2 pi, which also is 0, multiplied with cosine to x2. So we obtain that this is 0 and this is 0, so these two are identical on these 2 points. So all over these sides, the u is 0 here and here. So the periodicity condition is satisfied. It may also now be the case that it's equal to 0 on this boundary. If that is so, then the function is not only periodic, but it's also a member of W0. But this we must check. Well, we now consider a point here, and we are going to consider whether u is equal in these 2 points. So u of x1 0 is equal to sine x1, just replace now x2 by 0, and cosine of 0 is equal to 1, so we now get sine x1 on the left side. On the right side, u of x1 2 pi, we replace x2 in this expression by 2 pi and obtain that cosine of 2 pi is equal to 1. So then we obtain that the left side and right side are equal to sine x1. So the periodicity condition is satisfied. However, it is not equal to 0 on these 2 boundaries. It's equal to sine x1. So the function is not a member of W0, but it is a member of W pair.